Hi Ria, so I'm going to answer your question of how many moles of bromate ions are used in this solution where the initial volume is 0 milliliters, final readings are at 37 milliliters, and you said the concentration for the solution is 0.0180 molar for, you said krypton bromate, but I think you meant potassium bromate. If it is krypton bromate, you can use the exact same formula. Nothing changes because we're not actually using the krypton in this. But so to start off, we need to figure out our change in volume. You said final is 37 and initial is 0. So final minus initial is 37 milliliters of, I'm going to go with potassium bromate. The same thing will work. All right, for our next step, we know that we are given molarity. Molarity is, oops, not that one, moles per liter. So for us to use molarity, we need to have moles. We need to have liters. Well, right now we have milliliters. So our first step, I would say, is to convert to liters, because that's a pretty simple conversion. We do that by saying there are 1,000 milliliters per 1 liter. And this is in all liquids, including aqueous solutions. So this whole across multiply divide thing, this is known as stoichiometry, and you'll see what that entails soon. So with this in mind, we can cross out milliliters because now we've canceled out our milliliters and we know our units are in liters. For next, let's use our molarity that we were given. You said 0.0180 moles of potassium bromate in per liter is your molarity. That's M. So like the sign for molarity, the letter is a capital M. So now we can cancel out our liters. Sorry about the smaller lines now. All right. Now we have moles. Next thing for us to do is to find out how many ions, how many bromate ions are in each mole of potassium bromate. So next, there is 1 mole of potassium or of bromate ions in each mole of potassium bromate. Now I'm going to give you an example here. Say that instead of potassium bromate, we had calcium bromate. This is a 3 and this is a 2, by the way. So that would mean that we have 2 moles, because there's a 2 bromate ions per 1 mole of calcium bromate. Let me know if you don't understand that in the future. But in this case, we are simply using 1 mole potassium bromate, and in each mole of that, we have 1 bromate ion. So we do this by multiplying and dividing across. So I like to, I finished one thing. Switch back to blue. We've canceled out moles of potassium bromate, moles of potassium bromate. Now we are left with just bromate ions. That's what you want your answer in. So to do this, we cross multiply. So we say 37 times 0 divided by, times 1 divided by 1,000 times 0.0180 divided by 1 times 1 divided by 1. You can put this all into the same row of your calculator and it won't change it. And that gives you our answer of 6.66 times 10 to the negative 4th bromate ions. I hope this helped. Bye.